So I guess we should start. The question is finding minimum in rotated sorted array. So array is rotated in the sense like 4, 5, 6, 7, 0, 1, 2. So rotate it 4 times and we have to find the minimum. So it's pretty easy. We can just iterate and find the minimum, but that's not how you're going to do it. We have to do it in we have to write an algorithm that runs in O of L log in time. So let's just come and see how can we do this. Suppose we have an example that says 6, 5, 4, 0, 1, 2. So what is going to happen is that let me just make this clear. What's going to happen is that we start with here. This is left and this is right. You're going to apply binary search on this. But how we do apply binary search? Binary search is done in a sorted array, right? It's not sorted. But yeah, there is. It can be done. Let me show you how. In the array sorted, it's just that it's a bit rotated. Okay. So what happens here is that we we go and we'll be first we're on 6 and 2, and what's going to happen is that we'll start with finding the mid, and mid is like this is the index 0, 1, 2, 3, 4, 5. 5, 1, 2 is 2, 0, 1, 2. So this is our mid for now, and we'll be checking if our left is less than right. So which is not, left is less than right, 6 is greater than 2. Then we find out the mid, and we check if mid is greater than right. Mid is greater than right. Yes, it is. Mid is greater than right. So our new mid is going to be this. So our new mid is going to be this, or I could have just made this instead of erasing it up. So this is our mid. This is our mid, and we have to. Uh, sorry, this is going to be a left. So left is going to be mid plus 1, and like what do we need to do now is uh, this is our new mate that is left plus 1, and now what we'll do now is that the left is at 3 and the right is at 5, and new mate is going to be now at, excuse me, new mate is again we check if left is less than right. So yeah, left is less than right, left is lesser than this element. So we will be able to return this, right? We will be able to return this element. If this wasn't, we would have done that again, putting the left at mid plus 1, or putting the right at mid. So now like we have got this number. So let's just write this code for this. While left is less than right, what we are going to do, we'll check if nums of left is less than nums of right, and if that's the case, we'll just return nums of left, which we did in the case that we understood, or else we are going to do left plus right integer division by 2, because that's what we do in binary search, right? And if nums of mid is greater than nums of right, so if the nums of mid, the nums in the mid is greater than nums in right, so what we are going to do is we are just going to, we know that it's greater, right? We're going to go on the right side by putting left equals to mid plus 1, or else we are just going to do a right equals to Med. All right, because the numbers are lesser, right? So we can't just do mid minus one because at the very position that can be the smallest numbers. And what happened in our last case because there was zero present. So yeah, that's like what we are going to do. Return nums of left. And yeah, like that's it. That's what we did here. And this instead of returning this, I'll just do this, and this will return nums of left. Or else if that's not the case because left is less than uh, if it's equal, I mean if it's equal, so left is going to be the 0th index, and this will just return, and we have a constant because one is the at least length of the array. So if we do this we get what we get, nums right equals length of nums minus 1. Okay, just a typo here. So yeah, it is okay. Then see you in the next one.